6.6 Function Operations Part 1. Part 1. So when you have functions, we typically will call them by a name, like f of x, g of x. That's just a name, just like how we all have different names to call us so that we know what we're talking about. We can do arithmetic with those functions. So adding, subtracting, multiplying, dividing. So there's two ways that we can represent the same type of problem. Here's adding, both of those are adding. Here's subtracting, multiplying, dividing. Both of these, you have to make sure that the function of g cannot be 0 because you can't divide by 0. So what if I have these two functions, like right here? Here's the function of f, so it's just naming this whole thing as the function of f. Here's my function of g. So what if I add? This is saying add them together. So I take my function of f, so 4x plus 7, I'm going to add my function of g. So once you write it out, then you want to see what you can combine. So both of those are x's, so I have a total of 5x. I can't combine anything with my square root x, and I can't combine anything with my 7. So this right here would be my final answer. Okay, what if I'm subtracting? Subtracting is a little bit different. So I'm still going to write my first equation, so my function of f, 4x plus 7, subtract. This is very, very important. Parentheses right here. Here's my function of g. So again, my function of f was given here. Here, subtracting my whole function of g, which is here. So subtraction, you have to be careful because subtracting means you're subtracting the whole thing. So what I really have is 4x plus 7. I subtract the square root of x. I subtract an x. Now again, these still are like terms. So 4x minus x would give me 3x. This is a negative square root of x plus 7. Bing, bada, boo, adding and subtracting. So I want you to try to do the b by yourself. So adding, here's my function of f. Here's my function of g. You should have got 2x squared plus x plus 5. Subtraction, again, this has to be in parentheses. You're subtracting both of these terms. Both of these terms have to change their sign. Subtraction is basically the opposite sign. So this becomes negative, this becomes positive. 2x squared minus x plus 11. So now we're getting to multiplying and dividing. So now when I'm multiplying, I'm taking this first function of f. So notice how I put them both in parentheses. And then my second function of g. So you have to multiply everything here with everything here. You have to distribute. I personally am going to do it with the box method. You can do it by distributing it with your rainbow. That's fine. I'm going to do it with the box method. So I make sure that each term here is being multiplied by each term here. I especially do this when I have one that has 3 terms. Right now I have a binomial, so 2 terms times 2 terms. So I multiply to get inside the box, x times x squared, x cubed, x squared times 3, 3x squared, x times negative 9, negative 9x, and 3 times negative 9, negative 27. Once you're in the box, or once you distribute with your rainbow, you want to see if there's anything that you can combine. In this case, we don't have anything that we can combine, so this right here is my final answer. When I'm dividing, I put the whole function of f right here, put that on top. I have my function of g on bottom. When I'm dividing, I have to see if I can factor. So here, because this is a squared, and this does not have a squared, I'm looking for numbers that multiply to get negative 9, that add together to get 0, which would be x plus 3 and x minus 3. Okay? I also, once I factor, I have to look at the bottom, just the bottom of the equation. This bottom of the equation cannot equal 0. So I have to make sure to represent that can't equal 0. So I have to subtract 3 so I can figure out what x can't be. So x cannot be negative 3 because that would make that 0. Now I look to see if I can simplify. Only if there's multiplying. You can't just cancel just an x because x is being added. But this whole thing is being multiplied by that whole thing. So I can cancel this out, just like if this was a 5 over a 5. So I'm left with just x minus 3. So you need to have x minus 3 as your answer with this restriction because of the bottom. Right now I want you to try to be multiplying and dividing by yourself. So again, I'm going to do it with the box method. So I'm going to multiply inside each box to see if I have like terms. So if you didn't do that yet, you should set it up and try to do it yourself. You should get 9x cubed minus 30x squared minus 23x minus 4, because these two combine together and these two together, combine together. So now you divide. You're going to have to factor this. So when I'm looking at top, this whole equation, 3x squared minus 11x minus 4 goes on top. Now sometimes, if you're trying to factor, you want to guess and check what numbers multiply with these two coordinates. Now, numbers. So I have to split up my 3x squared. So one has to have a 3x and one has to have an x because these have to multiply to get 3x squared. I have to split up a negative 4. Since this already has a plus 1 with the 3, I'm going to try to do this to be plus 1, this to be minus 4. So then these two together multiply to get that negative 4. This is me guessing. Now I have to check. I check my outside. So if I were to multiply these together, I would get negative 12x. If I check my inside, I would get a plus 1x. And together, those give me a negative 11x, which is what I have. So that would be factored. So sometimes when you're dividing, it's nice to have a different parenthesis to kind of give you a hint how to factor it out. Now again, you need to make sure that you have what x cannot equal, because you cannot divide by 0. So this bottom cannot be equal to 0. If I want to get this x by itself so I can figure out what x should not be, I have to first subtract this one over, subtracting it over to balance it out, and then I'm going to have to divide by 3 because that's multiplying. Opposite of multiplying is dividing. So x can't be negative 1/3. If x is negative 1/3, that would make that 0, and it can't be. Here I'm multiplying, so I can cancel these because they're the exact same. So I'm left with just x minus 4 as my answer, with x cannot equal negative 3. Multiply, divide. And the last one. What if here's my function of f, here's my function of g, here's my equation I'm trying to figure out. Saying 4 times my function of f. So if I'm going to write this out, it'd be 4. My whole function of f is 3x squared minus 11x minus 4. Subtract to my function of g. Here's my function of g, so instead of writing the function of g, I actually write what the question is. I'm going to distribute that to each of these. So 4 times 3 would give me 12x squared. 4 times negative 11 is negative 44x. 4 times 4, and since this is negative, it would be negative 16. The subtraction stays with that too, so this is a negative 2 times 3, which is a negative 6x. Negative 2 times 1 is a negative 2. Now I can combine any like terms. So here's 2 x's, so I can combine those. Here's numbers, I can combine those. So I have 12x squared, because there's nothing can combine with that. Negative 44 minus 6 would give me a negative 50x. Negative 16 minus 2 would give me a negative 18. And that's the first part of functions, because they're so much fun. Have a grand day.